Case 1, half-Atwood machine with friction. In the diagram, you can see mass 1 on the table, mass 2 off the table. They're connected with tension, some sort of rope, and mass 1 is moving to the right, mass 2 is moving down. Step 1, free body diagram. On mass 1, you can see force of gravity pulling it down, but then force of the normal force is pulling it back up. The force of tension is pulling it to the right, and force of friction is pulling it to the left. Mass 2, you got force of tension acting upwards, and force of gravity pulling it downwards. Step 2, we got to analyze the situation, simplify some labels, since acceleration of 1 is equal to the acceleration of mass 2. Since they're equal, they're moving as 1. We're just going to call that acceleration A. Since tension 1 is equal tension 2, just going to call that tension, force of tension. Step 2. Step 3, we gotta write Newton's second law. So net force is equal to mass times acceleration. This for 1. For mass 1, that acceleration will be positive. And then net force for 2 is, that's going to be negative. Step 4, we got to find what actually the net force is. And for number 1, that's going to be the force of tension minus force of friction, because these cancel out. So we're just looking at right here. So that's force of tension minus force of friction. And then F net 2 is going to be force of tension minus force of gravity. And now we got to combine these two and these two for step 5. And that's going to be positive M1A is equal to force of tension minus force of friction, because these are both F net 1, and so we can just substitute. And then for this one, we got negative mass times acceleration, because it's moving down, equal to force of tension minus force of gravity. This is on 2. This is on 1. This is on 1. Step 6, we gotta expand, simplify, because we know force of friction. Force of friction can be written as coefficient of friction times the normal force, and the normal force can be written as force of gravity, and force of gravity we know is, we're going to keep that coefficient of friction, is mass times gravity. So we got force tension minus force of friction, also minus force of coefficient of friction times mass 1 times gravity, and that's equal to mass 1 times acceleration. For mass number 2, this force of gravity can be written as mass 2 times gravity, and so we got force of tension minus mass 2 times gravity. That's equal to negative mass 2 acceleration. And then we can plug one of these equations into the other because they both have these. And so we're going to make this equation equal, we're going to move that to the other side. We're going to do A plus mass 2 times gravity. And so since we got these two force of tensions, going to substitute. And so negative mass 2A plus into G minus coefficient friction mass 1 G equal to the positive M1A. So yeah, that's step 7 is plug these in. Step 8, we're gonna combine like terms. So we're gonna move everything with a G on one side and everything with an A on the other. And so we're just gonna move this over here. So we got G minus M1 G, and that's equal to M1A plus M2A. All right, we're gonna combine like terms, and then we're gonna simplify both sides of the equation next. And that's gonna be, we're gonna isolate gravity on this side, and we're gonna isolate acceleration on this side. So we're gonna acceleration times M1 plus M2. On this side we got gravity times M2 minus coefficient of friction M1. And we are solving for A because we're trying to find A. A is the same for both sides. So step 9 is simplify both sides of the equation, and then step 10 is solve for A. And so we just got to divide this side, both sides actually, by M1 plus M2. Cancel that out. M1 plus M2. That leaves us with, we put A on this side, A equals gravity times M2 minus coefficient of friction times M1 all over M1 plus M2. All right.